So in this video, we're going to convert from rectangular coordinates to polar coordinates. It's a little bit more complicated, but it's not too bad than converting from polar coordinates to rectangular. So how to convert from rectangular coordinates to polar coordinates? So we want to find the polar coordinates of a point whose rectangular coordinates are 0, 3. Okay, so the first thing I would do, so step 1, plot the point xy. So just plot it first. So I go over 0, up 3. So that's 0, 3. 1, 2, 3. Okay? So I see it. I see what it takes to get there. All right? Now step 2. Okay? Determine the distance r. Let me fix that. Distance r from what? From the origin to the point. Okay, so how far is it from the origin to the point? It's a total distance of r equal to 3. Okay? The last step, step 3. Now, it's not always that easy. Typically, you're going to do this by taking r equals the square root of x squared plus y squared. It just so happens that one, your x was 0. So if x is 0, it's the square root of y squared, which is equal to y. So it's just the y value for that one. So it's not always that easy. Okay, but that's in general. R equals square root x squared plus y squared from the Pythagorean theorem, distance formula, okay? If you're doing the distance between the point 0, 0 to x comma y, then you think about it, it's x minus 0 squared plus y minus 0 squared. That's where that's coming from. That's that distance, okay? Now step 3 is determine theta. Now once again, this one's easy. Theta from here, we rotate up 90 degrees, that's pi over 2. So that tells me that this is going to be r equal to 3. So r comma theta is 3 comma pi over 2. Okay, so typically it's not that easy. And so what I always end up doing is I take advantage of tangent of theta. So if I have some point, x comma y, this is my x, this is my y. Tangent of theta is y over x. So to get theta, I do the arc tangent of y over x. So in general, that's what the formula is. Okay, so this is the point right there. That's your xy point. All right, let me move this around. So now it kind of matches up a little bit. Okay, so these are your 3 steps. Step 1, plot the point. Step 2, determine the distance r. Step 3, determine theta. And if it's as easy as that first one, then you're good to go. If it's not, you might need to use these formulas. Okay? So how to convert from rectangular to polar. Okay? So say you have the point xy equals 2 comma negative 2. Okay, so the first thing I want to do, I want to plot my point. So I go over 1, 2, and I go down 1, 2. So this is the point 2 comma negative 2. Now how would I do this? Okay, how would I do this here? Well, if this is my polar axis, okay, I'm going to rotate down some negative angle. Okay, I don't know what that is, but what I do know from my triangle is that this side is 2 and this side is negative 2. So I can find r. Now r squared equals 2 squared plus negative 2 squared. So this equals 4 plus 4, which is 8. So r is equal to plus or minus square root of 8. And I'm going to do the positive because it's this distance between the pole and this point here. So that's the positive square root of 8, which equals 2 square root 2 if I simplify. So this is 2 square root 2. Simplify. Square root of 8 is, 8 is 4 times 2. Square root of 4 is 2. So I get 2 square root 2. Okay. So I know that my r theta, I know my r is 2 square root 2. And I know that my theta is going to be negative since I'm rotating in the counterclockwise, or actually the clockwise position. I just need to figure out what I'm rotating exactly. Okay, so how do I do this? Well, the tangent of theta equals what? It equals opposite over adjacent. So opposite over adjacent, which is negative 1. So what do? I do theta equals the tangent inverse of negative 1. Okay. So what mode am I in? I'm in degree mode. So tangent inverse of negative 1, enter. That's negative 45 degrees. That's negative 45 degrees, or negative pi over 4. Okay. So nothing to it. All right, that is the polar form. This is rectangular. All right. If you wanted other forms, I suppose you could get other forms. Like here's your point 2 comma negative 2, right? Well, instead of going down a negative theta, if you're not into that, you can go all the way around like this, right? And still get it. And so that would be a theta of 7 pi over 4. And so your point here would be what? It would be 2 square root 2 comma 7 pi over 4. So maybe if you're asked to have your theta between 2 pi and 0, then that's the type of answer that they're looking for there. Okay, so if they're not, keen on having that negative theta there, whatever they're asking for, you just adjust to make it work. Okay, let's try another one. So we're given negative 1 comma negative square root 3 rectangular, and I want to find the polar coordinates. Okay, so to do this, first thing I'm going to do is I'm going to draw it. So I go over negative 1 and I go down negative square root 3. So this is the point, negative 1 comma negative square root 3. Okay, so if this is my polar axis. Okay, I can rotate around some theta, and I go out some positive distance r. That's one way to do it. Okay, so how do I figure out what's going on here? I'm going to draw a triangle. Okay, so I know I'm going over -1 and down negative square root of 3. So I need to figure out what r is. So how do I do that? I use Pythagorean theorem. -1 squared plus negative square root 3 squared equals r squared. So 1 plus 3 equals r squared. So 4 equals r squared, which tells me r is 2, not 4. So r is equal to 2. Okay, so I've got that going on. Okay, now I need a theta. So I can use trig here. With this triangle, I can use this theta, and then I can do opposite over adjacent for tangent. So the tangent of theta is negative square root 3 over -1. So the tangent of theta is the square root of 3. Okay, so square root of 3, so theta equals the tangent inverse of square root 3. So tangent inverse square root 3, this should be one of those that you know. That's 60 degrees. So theta equals 60 degrees. Now, you got to be careful here, okay? Because if we're looking for this blue theta here, so that tells me this little part right here, this is 60 degrees. But what do we know about this first part of the blue going on right there? That's 180 degrees. So theta is 60 plus 180. And so what is that equal to? I guess that'd be 240 degrees. Oh man, and I guess that would be like, if I multiply 240 times pi over 180, I think that gives me 4 pi over 3. Okay, so 4 pi over 3. So theta here is 4 pi over 3. So rotating all the way around there is 4 pi over 3. So that point, okay, is 2 comma 4 pi over 3. Okay? So, once again, that doesn't have to be the only point. The cool thing about polar coordinates is there's infinitely many solutions, but that is one that's restricted where theta is between 2 pi and 0. Okay, so maybe if that's, the requirement, I don't know. You might have some requirement like that, maybe not. But that's the key right there. So the formulas that are very important for converting from rectangular to polar is a Pythagorean theorem. R squared equals x squared plus y squared. And tangent theta equals y over x if x is not equal to 0. Obviously, we're not going to divide by 0. Okay. If x equals 0, then you know, just like that problem that we did right at the first, when x equals 0, literally you just count the tally marks till you get to the point 0, 3. Okay, so you don't have to use this formula. All right, so those are the tricks there. You got those down, you got it. So just running through steps from converting from rectangular to polar, always plot the point first. Okay, figure out what quadrant you're in. That's going to help you draw your picture, your triangle. Then 2, if x equals 0 or y equals 0, you just find r from the picture. Okay, it's literally going to be on one of the x or y axes. But if x is not equal to 0 and y is not equal to 0, you use your formula right here. Okay, take the square root of both sides. And then the last step to get theta, if x equals 0 or y equals 0, you're going to be on one of the axes, and you already know that this is 0, this is pi over 2, this is pi, and this one is 3 pi over 2. So that's, I mean, you got it. You don't have to use tan inverse. But if you don't know it, then you can do tan inverse of y over x, just like you can do square root of x squared plus y squared. Okay? So hopefully you got it nailed by now. Okay? All right, good luck.